Hey guys, I'm Adam, and this is week 4 of our math section of the SHSAT course. And today we are going to be talking about ratios, proportions, and unit rates. So before we begin, like usual, I'm just going to bring up a few key points that I think you guys should know when approaching these problems, and then we're going to go into a few practice problems. So my first key point is write out the units. This is very important because a lot of times students will do all the math right, they'll do everything right, but they'll mess up the units. And then there will be times when you'll get the same answer choice, the same number, but different units. And a student won't think twice, they'll circle something and they didn't keep track of their units. And this is such a stupid way to lose points, right? So always write out your units when you're multiplying and doing operations with these types of problems. And it's also especially helpful to actually go back and check your work, because if you set up all these proportions correctly and all these units correctly, everything should sort of cancel out and leave you with a clean answer. So that's another way to check that you're doing your work right. My second key point for you guys is to actually understand what is being compared, because ratios, proportions, and unit rates are all just essentially comparisons of different quantities. And so when you're approaching these problems, you need to know how to set up comparisons and proportions to be able to isolate and find the missing values. And so you just need to know what units you're comparing to what and what you're ultimately trying to find, because that is actually how you set up and solve these problems. And my third key point is to actually know how to find the unit rate. And first of all, a unit rate is just the simplest way to write something. So for example, here we have miles per hour, and that is basically how many miles can you go in 1 hour. The denominator is in its simplest form of 1. So another example would be like meters per second, right? So meters per second, right? And that basically means how many meters can you go in 1 second, right? So this second part of the proportion is always going to be 1. That is a unit rate. Now, before we approach these problems, I just want to do a quick refresh on ratios, because we talked about fractions and decimals and everything, but we didn't really talk about ratios. So ratios are just another way to write a proportion. And that means that they can be converted into fractions, decimals, percentages, all sorts of things, right? So let's take the example ratio 11 to 2, right? So colon 2. That can be converted to 11 over 2 as a fraction, right? And when you do 11 divided by 2, you can get 5.5, right? So this is how we can convert into different forms. Ratios are very easy, right? You can, if you struggle with ratios, just convert them into one of these and you'll be fine. And the colon literally just means 2. So when we say 11 to 2, we're just saying 11 over 2, basically. That is an equivalent way to write that. Okay, so now that we got this down, let's go look at some practice problems. These are all of these problems were from the same SHSAT. So this just goes to show how many of these problems actually show up on individual SHSATs. So this is actually a very important concept, something that is tested quite frequently. So just make sure you know this. So here, our first question says, a bag contains 75 marbles that are red, blue, or green. The ratio of red to blue marbles is 15 to 7, and the ratio of blue to green marbles is 7 to 3. If 2 blue marbles are removed and replaced with 2 green marbles, what will be the new ratio of red to green marbles? So what can we do here? Well, we know that there are 75 marbles in total, and we know that they can either be red, blue, or green. Now, they give us 2 proportions, and they're basically comparing the different colors. So in this case, what I would do is just set up a little table. So we're going to set up R, B, R for red, B for blue, and G for green. And now the first proportion they give us is red to blue is 15 to 7. So we can write a 15 to 7, right? And every different proportion, we're just going to write like under and see if anything can line up. Our next proportion or ratio that they give us is blue to green, and they say that that is 7 to 3. So blue is 7, green is 3. So now we have these two, right? But we see that the blue has 7 for both of them. And just to show this in fractions, if you might be more comfortable with that, we can rewrite this as 15 over 7. We can write this as 7 over 3. So we see that these two 7s cancel out, and we get 15 over 3. So we can actually directly compare the amount of red marbles to the amount of green marbles because we have the same amount of blue marbles. So we can actually just rewrite this entire thing, red to blue to green, as 15 to 7 to 3. Right? Now that we have this proportion, right, we know basically how everything is divided up within these 75 marbles. But because we know that there are 75 marbles, we can just add up the total number of parts. And since every part here should be equal, right, then we can actually find out how much each individual part is. So we know that 15 plus 7 plus 3 is 25. So 25 times some number, which is what we're trying to figure out, is going to equal 75. And we figure out that that number is 3, right? So for each one of these represents 3 marbles. So now we can actually figure out how many red marbles, how many blue marbles, and how many green marbles we have by multiplying 3 by each of these individual values. So we have 45, right, 3 times 15, red marbles. We have 21 blue marbles, and we have 9 green marbles. So now let's look at the second half of the problem. If 2 blue marbles are removed and replaced with 2 green marbles, what will the new ratio of red to green marbles be? So we remove 2 blue marbles, so we subtract 2 from 21, that's 19. So now we have 19 blue marbles, and we add 2 green marbles. So we add 2 to this, so we get 11. And now it says, what will the new ratio of red to green be? Well, red is 45, green is 11. So we're just going to get 45 to 11, which is answer choice D. Okay, so let's move on to our next question. And here it is. On a bike trip, Rajiv traveled 65 kilometers in 5 hours, while Shayna traveled 72 kilometers in 4 hours. How much less was Rajiv's mean speed in kilometers per hour, kph, than Shayna's? Okay, so what is mean speed? Well, mean speed is distance over time. That'll give you your average speed, right? And in this case, it's also the unit rate. So we know that Rajiv, which I'll just write as R, traveled 65 km in 5h, right? 5 hours. And I'm writing my units here, right? I'm not forgetting that. That's important. And so when you divide that, right, you're just going to get 65 divided by 5, which is 13 kilometers per hour, right? Now, we also have Shayna. So I'm just going to signify that with an S, and that's the same thing. 72 kilometers, 4 hours, right? So we can just write 72 km over 4h, and that is equal to 18 kilometers per hour. And just to show it to you guys, if you want to do your long division, 72 divided by 4, 1, 3, 32, 8, 32, 0. So we get 18. So now that we know Rajiv's mean speed and Shayna's mean speed, they're asking us how much less was Rajiv's mean speed than Shayna's. So that's just, we can just subtract them, right? And because we have the same units for both of them, we can actually directly simplify this. If we had different units, then we couldn't simplify this. So because you write down your units, you can verify that what you're doing is correct, right? So now we have 18 kph, right? That's equivalent to kilometers per hour, minus 13 kph. So that's just equal to 5 kph, which is answer choice B. Okay, our next question. A roofing contractor uses shingles at a rate of 3 bundles for every 96 square feet of roof covered. At this rate, how many bundles of shingles will he need in order to cover a roof that is 416 square feet? So they're giving us this proportion here, 3 bundles for every 96 square feet of roof covered, right? This is our proportion that we can use to then find out our next part. This is what I was saying about understanding what you're searching for. So we are searching for how many bundles we need, right? So, and you can do this with ratios. I prefer doing this stuff with fractions, but you could do this with ratios. So what I'm going to do is I'm going to write 3 bundles, right? over 96 feet squared, right? And you could also reverse this. It should work if you flip it, as long as you're consistent. You don't have to write the 3 over the 96. It could also be the 96 over the 3. So this is going to be our converter, basically. This is telling us how many bundles are in 96 square feet. And you could take this down to the unit conversion if you want, but you don't actually need to do that, because we can set this equal to, because it tells us at this rate. So we can assume that this rate stays the same, right? So the ratio between the top and the bottom should stay the same for all different combinations of bundles and feet squared. So now we know how many bundles of shingles will he need in order to cover a roof that is 416 square feet. So X bundles, right? That's what we're looking for, over 416 feet squared, right? So now we can cross multiply, right? And then we can get, or we can actually, there's two ways we can do this. We can either cross multiply or see that this is directly proportionate to this. But let's just do some cross multiplication. So we get 96 feet squared, right, times X bundles. It's going to be equal to 3 bundles times 416 feet squared, right? So now we have X bundles and 3 bundles, and we can directly actually just do this. So what we can do here is we can multiply this 416 times 3, right? So we get 416 times 3, 8, 1, 3 plus 1, 4, right? 12. So that's the amount we have. And we know that this is 96, so now we can do our long division to figure out, to basically isolate for X, right? So let's just rewrite this, 96 feet squared times X bundles. I'm just gonna save time and write that as B, equals 1,248 feet squared times B, right? And now we can actually just write this as X times 96 feet squared B equals 1,248 feet squared B. And now that we have the same units on both sides, we can just cancel them out because we know that what we are doing is right. So now we have to do X times 96 equals 1,248. So X is going to equal 1,248 divided by 96. So now this is when we do our long division. How many times does 96 go into 124? 1, 96, 8, 28, 288, and that should be 3, right? So 3 times 6 is 8, carry the 1, 3 times 9 is 27, add 1, 28, and you get 0. So you get X equals 13. So now that we know that X equals 13, that is our answer, which is G. Now we have our last question here. Let's just look at this. A United States presidential coin is made from an alloy of 4 metals: copper, zinc, manganese, and nickel, with weights in the ratio of 177 to 12 to 7 to 4 respectively. The coin weighs a total of 8 grams. What is the weight of zinc in this coin? So we know the ratios, right? We know that we can write this because it says respectively. We know that copper to zinc to manganese, which I'm just going to write as M, to nickel is 177 to 12 to 7 to 4. Right, so now that we have this ratio down, we know that the coin weighs a total of 8 grams. So similarly to how we did the first one, we can figure out how many parts there are and then divide 8 grams by that many parts. So 7 plus 4 is 11. 11 plus 12 is going to be 23. And 177 plus 23 is actually exactly 200. So that's a nice number. So we have 200 of this parts, right? And that it's going to equal 8. So that is equal to 8 over 200, which we can simplify to 2 over 50, which is also equal to 1 over 25, right? So we know that x is 1 over 25. And you know what? We can actually write our units in here. So we know that this is 8 grams. So we know that this has to be in grams, right? Now, we know that the coin weighs a total of 8 grams. We already have this, so we know that x is that. And they're asking us for the weight of zinc in this coin. Well, going back to our proportion, we know that zinc is 12 out of this, right? 12 times this x, right? You can just imagine that we have an x times everything here, and all that together should equal 8. So we just have to do 12 times this, which is going to be 1 over 25 times g. So you get 12 over 25g, right? But we see here that all our answers are in decimal form, so we're going to need to convert this into decimal form. Well, we see that it's over 25, so we can just multiply this by 4 over 4 to convert it into a base of 100, and we're going to get 48 over 100 grams, which is just equal to 0.48 grams, which is answer choice B. Okay, so that's it for this video, guys. I hope this helped. Again, like usual, if you have any questions, comments, concerns, please put them in the chat. In the comments. We'll be very happy to answer them. And we hope this helps. Next week, we are going to release 2 more videos. So stay tuned and like and subscribe. Thank you for watching.